Good afternoon. Good afternoon. Hope all is well. Sorry for running a few minutes late. I got caught up in traffic, and so you know how that goes sometimes. All right.
Good afternoon.
Hey, how's it going? Oh, so like I said, once again, I apologize. So let's see. Where do we leave off in our notes? Where are all my notes? All right. So we didn't do 3.5. I think we just did 3.1 through 3.2. Stop right here. And you guys most definitely feel free to let me know if I'm incorrect, but I believe we did 3.2, did these, did notation, and we're picking up right here at the rest of 3.2. All right.
What
So
was that blue writing for empirical, or was that for another class?
say that again.
It was blue writing. You just scroll past it.
Oh yeah, that was from last. That was last class. That was just talking about what we were going to do this class. Yeah. So notice I said 3.2 empirical rule. That's what we're starting at right now.
Okay.
So once again, 3.2. I mean, empirical rule is still in 3.2. So we're still in 3.2, and then we don't do 3.3. We're going to go to 3.4 and 3.5. So just give you guys a heads up as to where we're going. All right. So the empirical rule, it says approximately. I try to shorthand it a little bit. Approximately 68% of the data is within one standard deviation of the mean. So that's SD, standard deviation of the mean. Approximately 95% of the data is within two standard deviations of the mean. And then approximately 99.7% of the data is within three standard deviations of the mean. So of course,
Excuse me, Professor. So I don't know if everybody else has it. I have all these notes. I believe we got far enough that we did the first example of the college students enrolled at
Okay.
university.
Okay. So we did this. Okay. I must be thinking about my other class. So did we get a three? So that was it for 3.2. If you guys already did three empirical rule, then that was it for 3.2. So just make sure, as far as notes are concerned, we good. So we
And then
did.
yeah, we finished up at ABC.
Okay, great, great. I must be thinking about my other class then. So sorry about that. I know one of my classes stopped right there, so it has to be my other class. Okay, thank you for that. I appreciate it. Most definitely appreciate it. All right, so that means we're looking at 3.4 and 3.5 today. Once again, we do not do 3.3. All right, so we're looking at measures of position and outliers. Right there and better. All right, so Z-scores. So it's not a 2, it is a Z. Z-score represents the distance the data value is from the mean in terms of standard deviations. All right. So there's a general way we can look at our formula. To calculate your Z-score is going to be the data value minus the mean divided by the standard deviation. Okay. And so here I was just showing you the symbolism that you would use for each. You know, if you were dealing with population, remember there's a different set of symbols that you would use versus your sample. So, but all of this means the same thing. Your data value minus the mean divided by the standard deviation. All right, just a few facts, two facts about the Z-score. The Z-score is unitless, and it has a mean of 0, standard deviation of 1. We're talking about actual conversion. So when we go to our Z-score chart, which we won't do for a couple of chapters now, but right now they're just introducing it, showing you how to calculate it. But what you're going to notice is that 0 is in the middle, which represents our mean. And then we go out one standard deviation apiece and all that stuff like that. So you'll see as we progress. But I believe my math lab asked you a question of that nature. So I want to make sure you had that. You know, when it comes to Z-scores, the standard. Your mean is 0, standard deviation is 1. All right. I'll scroll up if I scroll up too far. All right. So this first example says determine whether the Angels or Rockies had a relatively better run producing season. The Angels scored 773 runs and played in the American League, where the mean was 677.4 and standard deviation was 51.7. The Rockies scored 755 runs and played in the National League, where the mean was 640 and standard deviation 55.9. Try to write some of this better. I must have been rushing. Or I might have just been getting used to writing on this board. All right. So the first thing I would do, just like I do with any word problems, is write down the given pieces of information. All right. So when you look at your Angels versus the Rockies, and then also one thing that was pointed out, just in case you don't watch baseball, the American League has a few different rules than the National League. So that's why you can, set them up as different groups within the same, league, because you have your American League versus National League within Major League Baseball. So the Angels play in the American League, the Rockies play in the National League. And that's why the mean and the standard deviation is different in both. So in the red, I wrote down the information for the Angels. Our data value, our run producing season for the Angels, 773, have a mean 677.4 and 51.7 is standard deviation in the National League. I mean, the American League. Now in the National League, 640 and 55.9. And then the Rockies had 755. All right, any problems? Right now, all we've done was write down the given information, assign symbols to them, to the given information. All right, so now let's calculate the Z-score for each. So you do your data value minus the mean divided by the standard deviation. So the 773 minus 677.4 divided by 51.7. And so for the Angels, that's 1.85. Then for the Rockies, 755 minus 640 divided by 55.9. That gives us 2.06. All right. So always round Z-scores to 2 decimal places. It's going to matter later. So we want to go ahead and get you in the flow of doing that right now. When we actually start applying, using the application of Z-scores, we will need to round it to 2 decimal places. So what do these mean? And that will be in the green. The Angels scored 1.85 standard deviations above the mean. And the reason why it's above, or reason why we can say above, is because it's positive. Now, it is possible for your Z-score to be negative. Then let's say if it was negative 1.85, then you would say the Angels scored 1.85 standard deviations below the mean. So the fact that the Z-score is positive versus negative is, information that you will need. So 1.85 above the mean. And the Rockies scored 2.06 standard deviations above the mean. So this means that the Rockies had a better run producing year than the Angels. So it takes your actual data value and compares it to the average. It compares it to the mean of the group that you're involved with. All right, any questions? Any questions? All right, we scroll up. All right, next thing is percentiles. Let's write that better. All right, so we have the kth percentile of a set of data is a value such that k% of the observations are less than or equal to the value. All right. Kth percentile is denoted by P sub k, or you can just say PK. All right. So example that talks about percentile, just make sure we have an understanding. It says Jennifer just received the results of her SAT exam. Her SAT math score is 600. Her SAT math score of 600 is in the 74th percentile. What does this mean? All right. Try to give you guys a chance to write stuff down. So if her score is in the 74th percentile, that means 74% of the people who took the exam scored 600 or less. And then that means 26% scored better. And so we get that 26% from subtracting that 74 from 100. So that percentile will always give you less than or equal to. And once again, if you want to know more than or better, you subtract that from 100. All right. Scroll up, everybody good? All right, quartiles. Your quartiles will divide your data set into fourths. So notice our dividers, we have our maximum and minimum value as bookends. And then you have Q1, Q2, and Q3. And once again, they split your data set into fourths. 25% of your data will be in between each. All right. All right, so finding our quartiles. First thing we'll do is list our data values from least to greatest. Don't forget that step. A lot of people, if they're going to make a mistake, they forget that first step. You always want to list your data values or list your data values from least to greatest. Then we're going to find Q2 first. Q2 is the median of the whole data set, so it's going to split your data into half. Then Q1 is the median of the first half of data. And then Q3 will be the median of the second half of data. So really all three of them are just medians. They're middle values. Q2 is the median or the middle value of your first half of data. Once you break it in half, that when you look at that first half, the Q1 is going to be the median of that. And then the second half of data, Q3, would be the median of that. All right, any questions? So what I'm gonna do is list a few other steps and then we're gonna do it all together. So I'll give you the next thing. Your interquartile range, IQR. It is the range of your middle 50% of the data. And of course, if I scroll up and you're still copying, don't let me do so. But your IQR can be found by taking Q3 and then subtracting Q1 from it. All right, any problems? All right. Next thing, checking for outliers. Outliers are extreme values in reference to your data set. So over here, you see, you say it can be either very, very small or very, very large. Anyway. So we're going to have these fences. We're going to have an upper fence and a lower fence. The way we calculate that, upper fence, Q3 plus 1.5 times your IQR. Your lower fence will be Q1 times 1.5, minus 1.5 times your IQR. So if a data value is greater than the upper fence, then it is considered an outlier. If a data value is less than the lower fence, it is considered an outlier. Any questions? All right, so we're gonna put all of these steps into action. The next thing. Any questions before we do so? All right, we're gonna do it step by step. I'm gonna erase some of this stuff. All right, so first thing you want to do is list your data values from least to greatest. So I just went ahead and wrote the data set from least to greatest. But of course, they don't have to give you the data set from least to greatest. Now, also what I do is I count my number of data values. That's what I did right here. I have 18 data values. So when I list them from least to greatest, I go ahead and break them up into halves. So I go ahead and write out, if I have 18 data values, I go ahead and write out 9 and then write out the other 9. And that's what I did here. It's just going to help me when I go to break up the data values and everything like that. You don't have to do that. It's up to you. That's just what I do. And you notice right here, I already know the first half of my data is going to have 9 data values in it. Second half of my data will have 9 data values in it because I already counted them off. I already knew I had 18. So I break them up in that way when I list them out from least to greatest. All right. And those data values, 180, 189, 370, 618, 735, 802, 1185, 1414, 1657. Then in the second half of data, 1953, 2332, 2336, 3461, 4668, 6751, 9908, 10,034, 21,147. All right, so I'll put my color coded circles back just because they match with what I was doing. Yep, should have did that. We go back, there we go. All right, so now the first thing we want to do, well, we already listed from least to greatest. Second step is to find Q2. Now remember, when you're looking for the median, if you have an odd number of data values, then all you do is pick out the middle one. But if you have an even number of data values, which we have here, we have 18 data values, we have to take the two middle values, add them together and divide by 2. And so that's what I did here. I took 1657, 1953, add them together, divide by 2. I got 1805. Okay. Questions on that first one, Q2.
So 735 was the first half.
Now we haven't got, yeah, so we haven't gotten to 735 yet.
Okay, I was just making sure. So the green is to go with that, like what you
The green is
circled.
gonna go right here.
Okay, that's
Yep,
okay.
yep.
Making sure how you put the colors.
Yeah, I was doing the green as far as it's still in reference to that, but it's in reference to the first half of data. So you're gonna get your mean from this first block right here. I mean, not your mean, your median, which is Q1 from that first block. And then the blue one, you know, because it was just me playing around with circles and stuff, you know, and colors. But yeah.
I understand it is really helpful with the colors. So I'll just
Okay.
make sure I match
Cool,
everything
cool.
up. Go back and
All right.
note.
So going to that's an awesome segue into our next one. Next step, Q1. Now, this whole first half, the 9 values, is the first half of data. So if you want the middle value of the first half of data, all you're going to do is just pick the middle value because we have 9 values. Remember, if it's odd, if we have an odd number of data values, all you have to do is pick the middle value. And so that would be the 735 that she was alluding to. And so that's why Q1 is 735. All right. And then for the second half of data, the bottom 9, we choose that middle value, which is 4668. Once again, just want to reemphasize the process. If it was an even number of data values in the second half, then I would have to take the 2 middle values, add them together, divide by 2. All right. Everybody good?
I have a question. So related to the 735, so if I were to write out the top part and just line up by like number order, 735 would be the middle number, right?
Yes, it would be the middle number of the first half of data. Yes. And then that same thing goes with the 4668. It would be the middle value of your second half of data. All right. Everybody good? And so next, IQR. We take Q3 minus Q1, gives us 3933. All right. And now we get to determine our offenses, DET determine. And so our upper fence Q3 plus 1.5 times the IQR. 1.5 is a part of the formula. So so you're going to use 1.5 times your IQR. So this 4668 plus 1.5 times that 3933. And that gives us 10,567.5. Everybody done with IQR?
Is that a U or F? Is that unite? What does that stand for?
All right, let me make sure I'm with you. You talking about right here?
Yes.
Upper fence, UF.
Okay.
So I just shorthand what we wrote up there earlier in our first steps, just upper fence. And then here, LF, lower fence. All right, and then your lower fence Q1 minus 1.5 times the IQR. So that's 735 minus 1.5 times 3933. So 735 minus 5899.5. That gives us a negative 5164.5. So once again, that's your upper fence and your lower fence. So I'll give you a chance to copy that down, and then we'll go to the next step to see what we're going to do with those. All right, everybody good? So now the question is, are there any outliers? Remember what we said back in our steps. If something is greater than the upper fence, then it's an outlier, or if something is less than the lower fence, it is an outlier. So now you would take these values, go back to your data set and say, is there anything greater than 10,567? Is there anything less than negative 5164? And the answer is yes. We have 21,147 is greater than the upper fence. So that was the only one. It is possible to have more than one outlier, but that was the only one that went beyond our fences. So that's the only outlier that we have. All right, any questions, any questions? Problem with any of those steps? We're going to do all those steps one more time in 3.5. 3.5 just piggybacks off of 3.4, just adds one extra step. So we're going to do this whole process one more time, you know, make sure we're good. But any questions up to this point? All right, everybody done copying? Can I go to the next thing? All right. 3.5, 5-number summary and box plots. So notice if you look at the 5-number summary, it's the same 5 values that we just finished discussing. You know, you, like I said, your minimum and maximum are your bookends, and then you have Q1, Q2, and Q3 in the middle. So when they ask for the 5-number summary, those are the 5 numbers that they're looking for. All right. Box plots. It's a graphical tool used to compare groups of data. It consists of a box with lines that extend to the minimum and maximum values that are not outliers. You'll see what we mean in a second. These lines are called whiskers. Outliers are represented by an asterisk. So that's a generic representation. Oh, my pen up. That's a generic representation of how a box plot would look. So you have your Q1, Q2, Q3 would be the lines in your box. Then lines that extend from the box will go out to your maximum and min values. Those are your whiskers, unless they are outliers. If they are outliers, then we're going to represent outliers as asterisks, and the whiskers do not extend to those values. All right, everybody good? So this next example is going to run through all the steps that we just finished running through, just add the extra step of doing a box plot. So it says give the 5-number summary and then sketch the box plot. All right, is everybody done with that top information before I scroll up? Anybody? Okay, so notice the statement that I wrote down here in red. Data set is not always written from least to greatest. Make sure this is the case before you move forward. And that's something I mentioned already, but I just want to keep emphasizing that only because it's something that keeps a mistake that keeps occurring. So I keep trying to drive that point home. Don't forget to write your data set from least to greatest. Trying to give you guys a chance to write before I scroll up too far. All right, so once again, first step is to write data values from least to greatest. This time I had 21 data values. So notice how I split it up. I did 10 as my first half of data. I put the 1 in the middle, and then I put 10 down bottom. So that's 21, 10, 10, and 1 in the middle. And that 1 in the middle is my middle value, my Q2. Remember, if there's an odd number of data values, all I would do is choose the middle value. All right. And so that's what I did for the first quartile. Q2 is the first quartile that you'll find, and that's 30.95. All right. Oh, I didn't read off the data values just to make sure everything's clear. So we have 1995, and those are decimals. So 19.95, 2325, 2332, 2555, 2583, 2628, 2858, 2872, 3018, 3035, 3095. We got 3213, 3323, 3353, 3668, 3705, 3743, 4142, 4247, 4917, 5463. All right. So as I listed them, it enabled us to just go ahead and pick out what Q2 was. Now, there are 10 data values. You need to find Q1 now. There's 10 data values in this top data set. So that's an even number. That means there isn't a legit middle value. So I need to take the two middle values, add them together and divide by 2. So that's what we did right here. 2583 plus 2628. Add them together, divide by 2 gives us 2606 as Q1. And then we have 10 data values in our second half of data, and we'll do the same. 3705 plus 3743 divided by 2 gives us 3724. So any problems or questions with our quartiles? All right. Find a IQR. Q3 minus Q1 gives us 1118. 3724 minus 2606. 1118. Now we're going to establish our fences, lower fence and upper fence. I think I had another class that I was talking to and they talk about limits. So some books call it left limit, right limit, but we call it lower fence and upper fence. So our lower fence, Q1 minus 1.5 times the IQR, 26.06 minus 1.5 times that 1118. It's going to be 9.29. Then establish your upper fence by taking 37.24 plus 1.5 times 1118, 54.01. And in the red, just establishing, once again, why we find these lower fences, upper fences. If a value is less than the lower fence or greater than the upper fence, it is considered an outlier. And remember, those are the values when you talk about your box plot that you will use as asterisks versus the whiskers connecting to them. All right, are we good? All right, so last up, determine outliers. 54.63 is an outlier because it is greater than that upper fence. All right. So let's go ahead and do a 5-number summary and then do our box plot. So 5-number summary. Doesn't matter whether it's an outlier or not. That has nothing to do with your box plot. What is your smallest value? 1995. Q1, Q2, Q3, we established those. And then what is your maximum value? 54.63. Now this, once again, has nothing to do with whether it's an outlier or not. What is your maximum value? What is your minimum value? That's your 5-number summary. Okay. So the fact that it's an outlier has nothing to do with your 5-number summary. That comes into play when we look at the box plot. All right. And then here would be a rough sketch of our box plot. So our minimum value was not an outlier, so 1995 is good. Here goes our Q1, Q2, Q3, our quartiles. Now don't forget, this is going to extend out, your whisker is going to extend out to the smallest and largest values that are not outliers. And remember, we found 54.63 to be an outlier, so our next value up was 49.17. So our whisker goes to 49.17, and then we use an asterisk to represent that 54.63, because that was an outlier. All right. Questions on that? Questions. All right, is everybody good as far as what's been said so far? Okay. So can I scroll up, everybody? Got it. All right, yeah. Okay, so this is where we are up to this point, right here in this orange circle. As far as math lab is concerned, homework, you have chapters 1, 2, and 3 homework that we're looking to knock out. And then that first test is just on chapters 1 and 2. That should be already available to you. Also, definitions, chapters 1 and 2. So with all that being a part of, our class doesn't end till like 3:20 or whatever, but I'm not going to do anything else new today because we're done with chapter 3. But I do want to give you guys room to do this stuff and not feel overwhelmed or whatever. So we're not going to do any more lecture today. Our next test is going to have 2, 3, and 4 on it. So that's why we're not talking about another test yet. So that's it for chapter 3. And like I said, homework, we're looking at 1, 2, and 3 now that you guys are responsible for. Because I only hold you responsible for whatever we cover, you know what I mean? So I don't say, okay, you're responsible for 4 yet when you haven't done it yet. So I hold you responsible for what we cover, and then we move from there. So as far as what we've covered, 1 and 2, 1, 2, and 3. And like I said, that first test is just on 1 and 2. And don't forget, for those who haven't sent them yet, those definitions for chapters 1 and 2, we'll, do soon. So questions on anything at this point?
I did have a question about your shorthand MML. One more time, what was that, please?
Oh, it used to be called My Math Lab,
Okay.
but it's just Math Lab for you guys. So sometimes I have a habit of doing My Math Lab versus just Math Lab. Yeah.
Okay. And test 1, we're not responsible. That's just what's coming up.
No, it's already posted.
Already posted. Okay.
Yes. So as soon as you're done with your chapter 1, chapter 2 homework and you're ready to jump in there, then it's available to you to knock out.
Okay. And we haven't touched chapter 3. That's why we're doing chapter 1 and 2.
No, we're done with chapter 3.
That was chapter 3.
Yeah, we're done.
Cool.
With chapter
Okay.
2's content. Chapter 3 is 3.1 through 3.5. And without doing, you omit 3.3. So we only have 4 sections. So we're completely done as far as lecture is concerned for chapter 3. And so that's why I was saying that now that's a part of what you are expected or held responsible for now.
Okay.
As far as homework is concerned. And I said we have not done chapter 4 yet. So that's why we test 2 is not on the table, because we haven't gotten into chapter 4.
Okay, I got you. Thank you.
Yeah, no problem.
What's the hard due date for the first test?
Now, you mean soft due date, because the hard due date for
the
us.
hard due date, I guess, would be October 18th. But
Yeah, exactly. So if you're talking about a soft due date, let me look at what's going on here. I would, because so we're probably getting to 4 next. I know I wouldn't want to be in chapter 2 past, because this Sunday is the 5th. Most definitely not past the 12th.
okay, I mean that's fine.
Yeah. Now if you don't get it done by the 12th, he just asked for a soft due date. I would say you would be putting yourself in a dangerous position if you're still dealing with chapter 1, chapter 2 stuff past the 12th. I would most definitely try to get it done as soon as possible. If you can get it done by the 5th, that would be better, because we're jumping in. We're done with chapter 3 now.
Yeah.
And then so I'm going to open up the floor for questions next class, but the only next move is for us to jump into chapter 4. You see what I mean? So most definitely I will be looking to get done with chapter 1 and chapter 2 by the 5th, but most definitely no later than the 12th.
Okay, cool.
Mm-hmm.
And then chapter 2 definitions, is that also due on the 1st?
Yes, preferably chapter 1 and chapter 2. Yeah, I told you guys the first.
Okay.
But once again, if you run it, just communicate. If everybody communicate with me, we'll make it out of this thing alive. We'll all be all right. So if by some chance the first come and don't have it done, don't just take a 0. Talk to me and let's make it happen, make it work, and I'll work with you. But yeah, that's the date that we're looking for chapter 1 and chapter 2's definitions to be done first.
All right, perfect. Thank you.
Yeah, not a problem. Anybody else?
How do we know if you received the email with our definitions? Because I sent mine the other day.
When you say the other day, how can you be a little more specific? You talking about yesterday?
Okay. Hold on one second. I have it in here. My bad. I'm sorry.
No,
I sent
you're
it
good. Thursday. Let me look through my stuff again, because you should have gotten it. Because I respond to stuff up till yesterday evening. I know I didn't. So if you meant other day by yesterday evening, then I know I hadn't responded to those. Let me look through them again. I'm looking for that name, right?
Right. Yeah.
Okay.
You're right.
Yeah. Let me look through my emails again. Matter of fact, I'll look right now. Hope I might have missed it, and that is possible.
And I sent it through Genius Scan, because that's what one of my teachers taught me how to scan documents.
Yeah. Okay. I see it now. I was hoping somebody would say something, because I didn't know, because I had never seen that before, and I didn't want to mess my computer up. Look, I'm getting
You
run.
are.
This is from the computer. Look, this is from the school. So if I mess this up, then I gotta pay for it. So my money not set up
Okay.
right yet. So yeah. Okay, now that I know I can click on it, I'll check it out.
Okay.
Hey,
Thank you.
for the scanning that you said that the teacher advised you, because I need help with something like that too.
I use Genius Scan. It's the app.
How do you spell that, or is there a way you can put it in the chat?
I could put it in the chat for you.
Okay, thank you.
Okay.
Yeah. So Miss Wright, you good to go? I just clicked on it, made sure it was straight. You're good to go. Appreciate that.
Okay.
Uh-huh. All right. Anybody else? Anybody else? All right. So if you guys are good, oh, somebody said something in chat. Oh, that was her doing Genius Scan. Okay. So if you guys are good, I'm good. Don't forget, this is an 8-week course, like your classmate mentioned. October 19th. It's a wrap for us, and I'll flow on into another 8-week course. So that's why we moving the way we kind of moving, and that's why you guys got to make sure you stay on top of this homework. And yeah. So really, for that chapter 1, chapter 2 stuff, I will be shooting to get it done by Sunday, so I can get it out the way and then get into chapter 3, chapter 4 stuff, and we roll from there. All right. So you guys have a good one. Be safe. If you have any questions, feel free to shoot me that email. Outside of that, I'll see you next class.
Oh, did you get my email for the schedule? Like just how you think the date should roll by about the stuff that I need to get done? Like just
Yeah. As a matter of fact, I was about to email you what I just said today about chapter 1, chapter 2 stuff. That's exactly because I just remembered, because I was supposed to send that this weekend and I forgot to get to it. But yeah, I'll send that to you right now. And what we can do is continue that, we'll look at 1, 2 when you should be done. And then when we get to 3, 4, when we can just keep going back and forth. So
yeah, I would just I know if you have like a long hard copy of like all the dates as a whole.
Oh, now that I don't really have, because normally, like I said, I just play it by ear as we go according to the lectures. So basically, because I normally don't put dates for any of my classes, I don't put dates out there until we cover the lecture. And then I say, okay, now by this date, because sometimes classes move different, like each class is different. And sometimes I may have to move slower in some classes allow me to move a certain speed. So I normally don't put a due date out there for those who actually have due dates, like my 161s. I put it out there when we get closer to closing out that chapter. So like now that we've done chapter 3, I will probably put a soft due date out there for chapter, and all the stuff like that as we progress throughout the course. So that's normally how I do my due dates. So say again.
Oh, I said that works.
Okay. So I'm gonna email you. I'm gonna email you in a second about chapter 1, chapter 2. And then, like I said, we can just keep going back and forth, dialoguing about dates, as far as, so it can help you stay on track. All right.
Thank you.
Not a problem. All right. So you guys have a good one. Be safe, and I will see you next class.
Thank you.
Thank you. Take care.
Thanks. You do the same.